Okay, this is 2.5 part 2. Okay, now we're going to go ahead and I'm going to show you how when you use a high degree polynomial and maybe using a 0 in synthetic division doesn't get you into a factored polynomial, how you just continue to go until you get there. So here's your function right here. This is a 5th degree polynomial. It's x to the 5th plus x cubed plus 2x squared minus 12x plus 8. Okay, now what we're going to do is we're going to use the synthetic division bar and we're going to put our coefficients in. Notice I'm putting a 0 right there because we skipped a power from 5 to 3. Then 1, 2, negative 12, and 8. And you're going to look in the calculator and you're going to get a 0 out. And I'm going to have you use negative 2. You don't have to use negative 2. You can use any whole number that you see, but go ahead and use one of those zeros. I'm going to choose negative 2. Now we're going to do our synthetic division. And you can see because that ends up a 0 right there, that was a factor. Now what you're going to do is you're going to go again with this set of numbers right here because we can't factor that. That would be 1 power less would be x to the 4th minus 2x cubed plus 5x squared minus 8x plus 4. That's not going to factor, so we're just going to keep going. Okay, and that polynomial, I don't have room to write it, but x to the 4th minus 2x squared plus 5x minus 8x, or plus 5x squared minus 8x plus 4. You type that in, you get another 0, and the 0 this time is going to be a 1 that we're going to use, and you do your synthetic division. And there again is a 0. Okay, so we're going to go to the next screen and we're going to take this one and we're going to write a polynomial with that one. So you started out with x to the 5th. You did synthetic division, which took you down to x to the 4th. Now you're going one more time and it's x to the 3rd. So here's our polynomial. Okay, x cubed minus x squared plus 4x minus 4. Now then, you don't want to do synthetic division again because you can factor this, and when you can factor, it's always easiest. So x squared, GCF, and that's x minus 1. Take a 4 out, that's x minus 1. Okay, now then you've got a GCF of the x minus 1 in each of these terms. So we're just grouping, and x squared plus 4. Now, setting both of those equal to 0, x equals 1 right here. Okay, x squared equals negative 4. You square root each side, so x is equal to plus or minus 2i. And there's all your zeros, okay? We got 1 out of the calculator, and we got negative 2 out of the calculator. So 1 was a 0, but it was a double root, wasn't it? Multiplicity of 2, because we got it out of the calculator and we discovered it as a root. So you list that twice, then you got a negative 2 out of the calculator, you list that, and then you have your plus or minus 2i. And there's your 5 zeros that you were looking for. 1, 2, 3, 4, 5. So that's how you just continue to go when you don't have a polynomial that were a factor. You just keep reducing that by 1 power, and then you use your zeros out of the calculator. Okay, the last concept that we're going to do is I'm going to give you a function, okay, and it's going to be a 4th degree polynomial, x to the 4th minus 3x cubed plus 6x squared plus 2x minus 60. Okay? And I'm going to give you this as a 0. And I want you to find the rest of them. So you have 3 more to find. Okay? So we're going to kind of work backwards on this. I hope that you remember 1 minus 3i is also going to be a 0 because those come in complex conjugates. Now, it's kind of hard to do anything, but what we're going to do is get started by using these as factors. If 1 was a factor, if 1 was a 0, we would list the factor as x minus 1. If 2 was a 0, we would list it as x minus 2. So we're going to list this as a 0 of x minus 1 plus 3i and x minus 1 minus 3i. Okay? Now, those are my factors. Watch close. Okay, I'm going to use the rules and the properties that I can. I'm going to distribute that negative, and then I'm going to rearrange this and manipulate it. We did this last year on a polynomial, on a set of factors. I hope you remember this. All I did is distribute the negative. Now then, I'm going to regroup this. Remember, associative property applies, so we're okay? Now look at this. Isn't this a minus b, a plus b? Square the first, square the second, put a minus in between. Okay, so when we square this, it's a binomial. So we do the binomial square. Square together, double square. X squared minus 2x plus 1. So square the first, square the second. When I square this, I get 9i squared. Put a minus in between. Technically, this is going to change that to a plus, so I have x squared minus 2x plus 10. Okay, now what I just found is this is a factor of my great big polynomial up here. If I knew how many times this went into that, I could find my other zeros. So that's what I'm going to do. I'm about to go to the next screen, and I'm going to show you long division using this as my divisor and this as my dividend, and I'm going to find the other factor. So what we're going to do is we are going to use our x squared minus 2x plus 10 right out here. And inside this long division bar, I'm going to put that long original polynomial, x to the 4th minus 3x cubed plus 6x squared plus 2x minus 60. That was the polynomial from the very beginning. So this right here that I found by using those factors, I'm going to divide it into this long polynomial, and I'm going to have the other factor. I'll probably have to factor that to get my zeros because that's what I started out being my goal, was to find all the zeros. So we're just going to use long division to factor this. Okay, here we go. Remember, we use only this term right here, this x squared. That's all we're worried about. How many times does x squared go into x to the 4th? And that's x squared times. And then you distribute. X squared times x squared is x to the 4th. X squared times negative 2x is negative 2x cubed. And then x squared times 10 is positive 10x squared. We draw the line, we change our signs, and we combine. These cancel right here. Those are gone. And I get negative x cubed. And this right here, 6 minus 10, is negative 4x squared. And then I bring down my 2x minus 60. And I go all over again. Okay? Now, how many times does x go into negative x cubed? Well, that's negative x times. And I distribute the negative x. Negative x times x is negative x cubed. And negative x times negative 2x is positive 2x squared. And negative x times 10 is negative 10x. And then I change my signs and combine. The x cubes go away, and I get negative 6x squared plus 12x. And I'm going to bring my 60 down. And here's the last round right here. X squared goes into negative 6x squared, negative 6 times. And then I distribute to all three. Negative 6 times x squared is negative 6x squared. Negative 6 times negative 2x is positive 12x. And negative 6 times 10 is negative 60. And you can see when I draw my line and change my signs, That's a factor. X squared minus x minus 6 is a factor. So here we go. We've got x squared minus x minus 6 went into our big, long polynomial, all right? So we factor that into x and x, 3 and 2, minus on the 3, plus on the 2. So there's 2 of the zeros, x equals 3, x equals negative 2. And then we have all of our other factors. Remember, we had a 1 plus 3i, and we had a 1 minus 3i, and this was a 4th degree polynomial, so there they are, the 3 and the negative 2. Those are the 4 zeros from that great, big, huge polynomial that had 2 zeros that were complex conjugates. So you take those, you put them into factors, you multiply it out and get the polynomial, you divide using long division, then you come up with your quotient, you factor it, and that gives you all your zeros. Here's 1, 2, 3, 4. That's kind of hard. Okay, and I know that was a huge, long, incredibly detailed lesson. So my gift to you is to be sure that you take these notes. Thank you very much for working so hard this week. I missed you guys. I will be back on Monday. You have no assignment. You do not have to do 2.5. I will be here on Monday to help you. So you guys have a great weekend, and I'll see you Monday. Bye-bye.